Eugenio, thank you for coming in. I mean, you have just a remarkable background, just extraordinary capabilities, and across so many different dimensions. So it'll be great to get added insights from you. So thank you for coming in and doing this interview.
Thank you, Stephen. It's a pleasure to be here.
So Eugenio, we did already an interview in the past where you described your your journey and inflection points in your life and things like that. So if you can just maybe do a quick summary of what you've been up to since we last talked.
Yeah, definitely. Well, a lot happened since last time, with artificial intelligence. I'd say GenAI became even more of a staple in our lives. I've been mostly still been in the data science and AI space, so still working on the algorithm side, mostly on the area of taking these algorithms might be developed by other companies, providing GenAI systems or classic machine learning systems, and implement them in production and trying to use them as much as possible to actually drive benefits to society and to people, while also driving profits to companies. I've been doing a few different industries from healthcare to finance, a few more. And what I've been very fascinated recently has been on the intersection of Gen AI versus classic AI and how it's also basically taking over the world.
So on the generative AI side, are you using some of the, Microsoft, for example, has an Azure AI sort of environment where they give you access to many, many different models and you can kind of choose the ones you want, or I would say many of the major vendors do that, right? Google has the same thing and others. Are you working in those kind of environments, or are you going sort of open source and then using those, or some kind of combination? Like, are you using a vendor for some of this?
Yeah, it's a great question. And I would say it depends. Usually vendors are great in terms of providing you the infrastructure. So all of the cloud providers, AWS, GCP, Microsoft Azure, definitely provide you with the right environment in terms of development environment and having the compute capability. So usually, yes, it's using one of those systems to be able to develop systems at scale. But then it's a bit of a question on whether to use large language models offline through open source packages. It could be OpenLlama or other open source packages versus using LLM vendors, like OpenAI or Anthropic, or all those companies. And usually it boils down, at least from what I've seen, on whether it's an at-scale capability or not at-scale capability, just because once a system is developed with an LLM, that's maybe an API call with a system, with a vendor, it tends to get a bit expensive at scale. And so sometimes maybe the offline solution might take a bit more work, but it does provide you to have an in-house solution that doesn't really require to pay and to keep on the expenses with an LLM provider. So it depends a bit on the application, but definitely using the large systems.
So you're indicating that you've been working in like finance and healthcare in different areas. So when you do this, are you doing sort of no code, low code, or you're because you're combining sort of classical AI machine learning with some of these generative AI models, right? So are you doing any sort of effective coding? If you are, then what languages are you using? I assume Python, but maybe others.
That's exactly right. So there are a few different ways to interact with machine learning. I do usually Python as the go-to. I was lucky enough to make an investment a few years ago in learning Python and really sticking to it. And it has paid off as an investment, because right now all of the infrastructure, at least most of them, use Python natively as go-to for data science, machine learning, large language models. And because I come from a technical background, I tend to do a coding solution. So actually coding the application. Obviously now with this level of complexity, there is also a level of abstraction. So there is not going to be any more coding of an algorithm. It's going to be reusing libraries, using AI libraries, Anthropic libraries, and so on. But it is still definitely a component of trying to code as much as possible to be able to also then have an in-house solution.
Are you, since you're not just doing generative AI, are you reading some of the latest papers. Like, for example, there was one earlier this year on Goro Arnold networks, so CAN networks. It looks like it could maybe 100 times better in some ways, though the underlying hardware isn't there to take advantage of it. But I'm sure now hardware vendors are looking at that. Have you looked at some of those things like that? Or I guess about a week ago, maybe a week and a half ago, there was a paper doing TTT or test time training, rather than, there's like kind of pre-training and fine-tuning and things like that. Then there's RAG. But there's this idea that you can get additional capabilities just by test time compute. But there's another group that's done test time training, and they got really good results with that ARC framework of, sort of this measure of AGI, and it seems like one of the best tests of AGI. Have you played with? I guess there's a number of sort of questions in there. Have you been playing with these alternative kind of systems or reading some of these latest papers and things like that?
Yeah. I've been trying to read as much as possible. One of the challenges that everybody has been experiencing is the speed at which new research developments are coming out. So it's a bit challenging to be able to always stay at the forefront, of these state-of-the-art systems. What I definitely have been playing with is with RAG, so retrieval augmented generation, just because it seems to be almost an even better solution, at least for the time being, in terms of improving performance of a system, applying it to specific domain, but also not having to go through the costs and also the challenges of fine-tuning. The fine-tuning is usually the go-to, but it obviously doesn't lead to specific knowledge always being transformed and translated into the actual learnings for machine learning. So with fine-tunings, sometimes it takes a bit of work to make sure that the algorithm actually learns those new thought patterns, so to say, and at the same time doesn't forget other ones. Well, with RAG, it's a bit easier to provide context and specific knowledge to the large language models. So I've been playing a lot with RAG with quite impressive performance. And I've played a bit less with the other systems out of the fact that you kind of have to pick and choose right now, which ones you want to develop some knowledge. But I've always been trying to stay, in the know with all of the algorithms. Just a bit challenging right now.
So, I play with Notebook LLM or Notebook LM. And in fact, I put it in my keynotes now. But these things come out and it's like, wow. And then it's no longer wow because everybody's using it. And I do futuristic keynotes. So it's interesting, it drops in September. People go, wow. And now it's like, oh, Jensen Wong, I use it, use it all the time. He's recommending it and things like that. So I'm always kind of struggling to put things that are really on the cutting edge. But then you put it in and then it becomes like commonplace. Are there any things that you're looking at that are sort of cutting edge that you think a lot of people aren't using, but are kind of like, wow?
Yeah, and Notebook LLM is definitely a great example there because it's something that's extremely useful, but then as you were saying, there's a small arbitrage window, so to say, between the early adopters and when it becomes fully adopted by the majority. I would say what has helped me in more of a general concept, just trying to understand what are the key main concepts to basically rely on rather than specific trends, just because there are many trends and it's really difficult to stay on top of each and every one of them. And some might fade, some might change, or there might be reliance on a specific system or provider. So definitely RAG seems to be one of those trends that is here to stay. Fine-tuning and also the concept of trying to apply large language models to a specific use case or to a specific business and developing vertical knowledge. Those are also some of the things I'm trying to get a bit more into. And also Notebook LM is another example of basically multimodal models. And that's something that I think also is going to be here to stay. So systems that tend to be generalizable enough to be able to take in many inputs, not just text, not just images, but a combination of both, and basically approximate also what we as humans do all the time.
Have you been able to get access to things that are sort of in limited release, like Sora, or maybe the full version of O1, not just the preview, or you see word of some kind of new tool or new capability, and then it's in limited release, but it doesn't go widely out there. Even voice mode was available months ago, and the version we're getting is kind of stripped down. When you play with it, it doesn't do what that original sort of early release picture what it looked like, right? And are you being able to tap into some of these versions before they are fully released, like Adobe, for example? I've been pushing them to try to give me access to their Firefly before it gets released. I know it's in sort of like limited release. And then what happens is I end up playing with things like Kling AI or others on the video generation side, because it's you find these companies, they announce it, then they do sort of like a small release to people, and then you see these other companies just say, you know what, we got one. You don't have to. You can get it now. Are you playing with some of those, or are you able to get some early access?
I've had been given access to a few of those, mostly text-based LLMs and systems, a bit less on the video and audio side, but definitely something that I was trying to get access to. I find it really fascinating to be able to see some of the new changes, new developments as early as possible. So trying to get into the betas of these programs. I've been playing around a bit more on the tech side with some of these tools, and it's fascinating. It's fascinating to see the speed at which the developments are coming. And that's a bit what's I find interesting right now. We tend to complain a lot about performance with all of these systems. But I would say that given the fact that it's basically been 2 years or so since we have a big revolution with ChatGPT, I do wonder what we're gonna get in the next few years with video, with new developments with Sora, new developments with Notebook LM, and so on. And so I think that's probably even more fascinating, is being able to see through some of these early releases what we're gonna get. And I would say that maybe when we used to be thinking ahead about the future a few years ago, we might have not as ambitious as we can be right now, and that's probably one of the most interesting aspects as well.
I saw this maybe about 2.5 weeks ago. This sort of mention of DeepMind's Gamma Scope, and then Neuropedia, where you can actually, it's an implementation, and where you can take a look at what Gamma Scope does. And this is this machine interpretability side. And have you played with that at all? And then sparse autoencoders. I remember an article, maybe it's an article paper dropping several months ago. It was this year, where they use sparse autoencoders to kind of do a heat map of how these things, these LLMs, these ARs are self-organizing. And it was interesting to see that it's sort of organized into specialty areas that get activated when you put it, when you prompt it, almost like the way our brain, our cortex is sort of organized. I thought that was interesting. And then this other piece that came out maybe a week ago, where they talk about machine interpretability with DeepMind. This tool, it's free, it's open source, Gemascope or Gemascope, I guess it's Gemascope, where you can see the activations happening, right? And then there's this thing called Neuropedia, where you can play with it, where you can see, you put in a prompt, you can see the kind of the words it's activating on. You can even see why it appears to make a mistake. It's not really making a mistake. It's just that it's missing, or it's going down a particular path of reasoning. And that's why it seems like it's a mistake. But when you look at what it's doing, it's actually not making a mistake, right? So if you prompt it with more context, they won't go down that sort of incorrect path. Have you looked at these sparse autoencoders? So that's the underlying technology. They're using sparse autoencoders to kind of see what's happening inside these things. Have you been playing with that at all?
I've looked a bit into sparse autoencoders. I would say it's fascinating, as you were saying, that we do see some parallels between the human brain, its neural networks, and how, yes, some of these representations for the artificial intelligence might remind us of some of the ways that the brain itself is shaped as having these activations throughout all of the regions. And what I do wonder, though, is when we'll be able to get to a point of interpretability that's human-like interpretability. With autoencoders, it's great to see how we can pinpoint to specific areas of a network as responsible to a specific action or specific characteristics. A bit like how deep learning used to have these layers, or at least still has, but it's a bit less hype right now. And how we could see in convolutional neural networks specific areas focusing on lines or parts of a specific object. But with autoencoders, we still lack a bit of the interpretability side, especially in terms of bringing these solutions to actual real-life applications. So I do wonder, and I think it's also one of the main areas of research right now, like when will we get that level of explainability and interpretability where we can truly understand what was the reason why the LLM got to a specific point. And some of the research recently on chain of thought reasoning, so trying to connect basically all of the decisions and all of the thoughts, so to say, of LLMs, it's definitely a good way in that direction. But I will say we still have a bit of way before having actual explainable models that become interpretable and become also more reliable for all of the non-technical stakeholders involved.
It's interesting. I was asked by Riley to help them with a series on generative AI, series of 3 summits. So I brought in speakers for the one in healthcare, generative AI, and healthcare, one in finance, and then also government. And I ended up not only recommending speakers for all 3, but then they asked me if I could moderate and be the MC for the one in government. So that means that I brought in the speakers, I emceed the entire summit, and I moderated each session as well. And this was quite some time ago, and that's where, it's interesting, RAG was sort of really at the early stages where people were using it, things like that. Then it becomes mainstream, right? So because initially it's like there's just something really interesting, then becomes everybody's using it, and then in turn becomes really widespread. So I'm kind of giving this context in what you're looking at. Is there something on the outlier or edge that you think we should be paying attention to, or you don't have time to kind of spend, because you're trying to create systems that are actually being used, right? So are there things that are on the outlier that you're experimenting with that maybe it's not widely used right now and you can talk about, or you prefer to stay in a kind of safe and tried and true?
I do try and try to break these systems as much as possible every time I can. And I would say one of the reasons is because when we go from research and development, or prototyping to real life applications, that's usually where AI gets into some challenges. It's usually what's called the last mile problem. So getting a prototype and bringing it into the hands of actual people, actual users. That's usually where things get a bit complicated, especially with AI. And especially in terms of what we're seeing right now with hallucinations and reliability. I would say one of the big blockers right now is how can we actually get these Gen AI systems to behave in a way that's actually reliable and consistent enough so that we can trust them in terms of providing insights or providing interactions in topics that are relatively sensitive. It might be finance, might be healthcare. So I do try to always test their limits, especially in terms of when do we start to hallucinate? And the question there is because if you look at domain experts or high-risk applications, then you definitely need a system that's highly reliable, highly consistent, and it doesn't change its answers, especially because it would be losing, and it does lose, the trust of all of the experts that might not be technical enough to know its limitations and to rely on them. So I'd say one of the areas I'm personally looking into a lot, but also it's probably one of the areas where we have to, as a society, to do some progress is on the reliability side, which is also why I was mentioning explainability, because if we can explain behavior, if we can interpret the LLM and understand why it made some specific decisions, then we can also understand how to avoid those errors, those hallucinations, and allow it to also then be reliable in all these other applications. I'd say that's one of the big challenges right now between the level of adoption we have and full adoption, full reliability in virtually every sector.
There's this company called Symbolica, and I think they're not close now, and I can get the audience to look it up, but I believe they invested in a company called Symbolica, and it uses another kind of way of doing things, algebraic categorical kind of AI. And have you? I guess you haven't looked at that yet. Sort of ones that have alternative ways to maybe where you don't have this problem, right?
I haven't looked into that specific application. I do know though that right now a lot of what at least gets done in production, in actual real life application, is to sometimes avoid more complex systems or generative AI and go towards more classic artificial intelligence, just because it's easier to manage. And sometimes artificial intelligence is actually just linear regression or logistic regression. But I do see a lot of possibility right now, because most of these high-risk applications tend to have some pushback in terms of using generative AI because of its lack of reliability, while something like logistic regression, gradient boosting might be still having its own challenges, but still be a bit more reliable and so be the preferred choice. But we definitely have a lot of possibility in terms of, at some point, using generative AI and its performance in these applications that require more sensitivity and more reliability.
So I have a few questions about the future of these things. So I'll lay out sort of the map of where I'm going, right? So do you think these are going to be AGI in 2-3 years? So that's kind of, let's park that. And then there's this, there was a kind of a massive flood of news, maybe about 2-3 weeks ago now, where, and a debate, right, where people are saying, oh, it looks like it's plateauing. In other words, that pre-training, massive amounts of early parameter building, that's now, we're not getting the same kind of results. And then this applies to scaling laws, and maybe the scaling laws are not all applied, but there's this reporting that it's plateauing, but then you see others saying, well, but if you put more compute on the inference side, then it's still scaling, right? So maybe the focus on the pre-training side or the fine-tuning stuff is not working like you're not getting all of these emerging capabilities as before. But if you put more compute on the other side, and this gets to like test time training or on the inference side, then the scaling is continuing. Where do you sit on this? Do you think these things are plateauing or not?
Yeah, it's an interesting situation, because as you were saying, we do see a bit of this plateau in terms of performance, and it seems that we've reached a wall in terms of putting in more money, more energy, and more computing power. It seems that we're having now marginal returns on that front, but then at the same time, we do know that the human mind is so vast that we definitely can find alternative solutions. And maybe the solution is on the inference side, on the actual scoring side, rather than on the training side. I usually tend to think that, yes, scalability and rarely follows a linear pattern, so to say. So I wouldn't be surprised if we actually were to reach a plateau where it's not actually the case that the larger the model, the better it is, and the more power, more compute we put in, the better it is. And I always think about the human brain doesn't take as much energy. It's extremely efficient. And so I wouldn't be surprised if we were to go towards a direction where we started with these systems that are really big and computationally expensive, take a lot of energy, but then we started defining them and go towards more efficient ones that maybe require less neurons, less parameters, and also less energy. Definitely that would be the ideal scenario. So I would say probably that's the direction we would go in any case, because of the wall that makes us have to go in that direction, or just because we find that that's actually naturally the right solution. And I'll say what it's interesting to me is how, we're mentioning AGI. We used to think that AGI was probably just a few years ago, 100 years in front of us. Not so soon, but now we're actually changing these estimates out of the fact that we're growing at, or at least AI is growing at a rate that's not linear. It's almost exponential, if not more than that. And so the question here is, how can we have better estimates, knowing that we're not really going at a linear rate, but at more of an exponential rate? So I definitely think that we're going to reach AGI in a few years, probably. And I don't think that the wall we're seeing right now in terms of limitations is going to be something that's going to stop us to get there, because I'm sure we'll find other ways. And you're mentioning already a few of them. And so it's fascinating to see how, yes, there might be some limitation in the current way that we've been approaching things, but I'm also confident that we would find different ways to approach the issue, maybe going away from sides of these large language models and more crafting in different ways on the scoring side and on the inference side.
I mean, there's this kind of spectrum of AI, right? And OpenAI laid this roadmap, and I'm just going to alter it a bit, but the spectrum mean like chatbots, and then you have reasoning, like the O1 model from OpenAI reasons like a PhD student anyways. And then I guess a few days ago, there was these models released from China, and they're open source, and they seem to match the best that we have here. In fact, maybe even a little bit better. So this controversy of China being behind, now maybe they're not, right? At least they produce more papers and things like that. And so there's kind of this Western idea that we're always ahead and never catch up, but it seems to be that flattening. So there's this spectrum of chatbots to reasoning to agents, agentic AI. And then there's this idea that you get sort of innovation happening, or master kind of AI. And you saw recently, I mean, maybe a week and a half ago at Microsoft Ignite, Satya announced 1,800 plus AI agentic ways of doing things. And then you could build on top of those kind of 1,800 agentic models, right? So do you think that agents then are a way to address this if we do hit a wall, that you produce these smaller ones that can do things? And Anthropic came up with this one that you can run on the desktop. So I may even buy an account and play with this stuff, but where it can actually run your computer. You just give it a task, and then it just goes and does things, and it'll retry, and it kind of goes through this reasoning, planning process of doing so. And that's the whole point of agents, right? It'll just, can you do it? Ask it to do something, and then it just self-iterates itself and working on this problem. So what do you think about that? What do you think about this kind of agent on the spectrum? And there was an AI scientist paper that came out maybe about 2 months ago now, or 3 months ago, and it can automatically do things, and then people are throwing stones at it, but others are saying, you know what, this is pretty amazing for a first edition, right? Have you, what are your thoughts on this? So
I definitely think agents are the right evolution of what started with text only. in terms of applications. So agents are definitely the next steps where we're going in terms of providing utility and providing an ROI to companies and to users. I would say I'm a bit less interested though on the agents itself. I would say the agent is more of an application, so to say. But what I find interesting is the ability of abstracting the concept of solving a task or answering a specific question. And it used to be that answering a question meant providing a textual answer and became also an image or a video. And now we're actually going in towards the actions. So I would say what you're saying about reasoning rather than actual just prediction of the next word is probably what I see us going towards. So this evolution of the systems not being anymore on the word generation side, but rather on the action side and figuring out applications and solutions that might be going beyond text, might be, as you were saying, leveraging computer, interacting with different systems, creating some text to be able to control terminal running commands and so on. Let's say where we're definitely going, and what's interesting to see is also this ability for these GenAI systems to abstract and go beyond just text. And that's probably also where we're going to reap a lot of rewards, just because intelligence itself, if we want to go towards this AGI concept, is not just going to be about text. It's probably also not going to need the vast amounts of knowledge that we're feeding it, but it definitely will require this ability to problem solve and to come up with a plan of action and then some specific actions towards that solution. So I definitely think that's positive to see, because it shows how we're going in the right direction. We're going in this direction towards reasoning and the reasoning models, and we're just then having these text-based models.
Yeah, I mean, Geoffrey Hinton won the Nobel Prize in Physics, him and his colleagues, and it's the first time you get computer scientists and AI winning a Nobel Prize, right? In fact, there was controversy. People were saying, hey, why is him and John Jumper, why are they, well, not John Jumper, I'm getting that mixed up with the one in chemistry. Mm-hmm. Well, why is Hopfield and him winning this Nobel Prize for their work in AI when there's other people in physics that should have gotten it and things like that? So I thought that was interesting. It's like a landmark, right? Where non-traditional people in other areas are winning these Nobel Prizes. And then the following week, you had Demi Hassabis, John Jumper, David Baker winning one in chemistry, but they're not chemists. And yet they want, because of their work with protein folding, right? Or amino acids to protein, 3D protein structures. And then, in fact, DeepMind has this thing called Alpha Proteo, where you can do protein prediction, not just based on existing proteins, and then you're trying to figure out the structure, but you can kind of synthetic protein structure, right? I think these are really quite interesting. But Geoffrey Hinton, when he won the Nobel Prize, this started kind of following up on all of his comments he's been making for over a year now. He left Google last year to say he could be more freely speaking about these things, and he did some talks at different institutes. At the Vector Institute in Toronto, did a keynote, did one at Oxford. After he won the Nobel Prize, he's making these comments. And now, again, I recommend the audience go directly and to see what he's actually saying. But my interpretation of what he's saying is these things are smarter than us. And we shouldn't think that we're special, because these things, even when we hallucinate, he's saying, or when these things hallucinate, he says humans do that too. They do it all the time. They're really kind of fabricating what they perceive to be what's going on around them, right? And sometimes it's really accurate, and sometimes it's not. And he's thinking that these things, because there's no boundaries, that they can be smarter than us, right? Or maybe not now, but shortly, as you mentioned, maybe in 1 or 2 or 3 years or more, but in the near term, not 2100. It sounds like you're in that camp, right? Because there's Gary Marcus and others are saying, no, you got to have this symbolic stuff in there too, or other kinds of hybrid models, which may be true. Who knows, right? But there seems to be a lot of faith in these existing ones that are, like transformer based, right? So
Yeah, and I think it's fascinating also how we're saying, concepts that go beyond the technical aspects themselves. You're mentioning the ability for a Gen AI system to hallucinate and have these behaviors that definitely are similar to humans. I say those are the aspects that to me provide the most interest and curiosity and fascination, and also sometimes obviously a bit of fear, just out of the fact that, and I come from a technical background, it used to be that these systems really had to be maintained and trained and generated and cared for, almost on a very micromanagerial type of level. But right now, these systems are on their own exhibiting these patterns that do seem fascinating, at least to me. Now, the fact that, and people say sometimes that treating Gen AI, with kindness and talking to them in a nice way, in the same way that talking nicely to perhaps a human being also provides better answers and a better interaction. We're seeing the same with Gen AI systems, where the sometimes ability for a human being to lie or to come up with ideas that might not be factually correct, but are definitely confident. We're seeing the same with these Gen AI systems. So I definitely find fascinating how, yes, these systems seem to be almost more powerful than we were expecting. So this leads to obviously a huge amount of ROI and potential impact, but at the same time, a lot of different questions on the ethical side, on the policy side, on the behavior side as well. And I'd say that's definitely where Hinton has some good points in saying that these systems are extremely powerful and we don't know also what we don't know. So there is a lot more for us to discover, not just about the systems that we will develop, but also about the ones that we already developed, because we keep on discovering new aspects for systems that have already been developed years ago. So it's fascinating.
yeah, and then this whole idea of embodiment within robots, and it used to be this idea that robots would be like the kind of the old idea of it's a mechanical arm and it has to be precisely sort of trained to do one specific task, and then now there's so much work on generalization, and so you have the Figure 2 robot being tested, or was being tested by BMW, and I think there's going to be a new testing of it, and January of next year, or early next year. They already got the Figure 3 one built, and they're kind of fine-tuning what. And then in March of this year, they showed the Figure 1 version where this guy is just interacting with it like in English. Like he's asking the robot, what do you see? The robot looks down and says, hey, there's an apple there, there's this and that. And then the guy says, like, I'm hungry. And the robot doesn't have to be told. It goes and picks up the apple and hands it to him, right? But it's not a mechanical picker arm. It has articulating almost like bionic arms, right? Where it mind you is fragile. So if you look at the Figure 2, it may not have that same degree of movement because that capability that they had in this test prototype, the experimental prototype, may not be able to be as rigorous and be maybe too fragile, put it into a production environment. So you look at the Figure 2, it may not have the same degrees of freedom in its articulation because they got to build it so that it's durable, right? So that's like a milestone, right? The generalization that's occurring in robots, and Unitree is going to release one for the home, and it's, I mean, if you have reasonable means, you can buy it. Right? I think it's going to be like under 16,000, which, upper middle class people will say, you know what, I've got a car, it cost me 60. I think I'll buy myself one of these $16,000 home robots, and the price will come down. So what are your thoughts on that? And then I'll get into an item where we did some talking beforehand. I think you said you're teaching at Columbia. I'd like to know what other new things you're doing. We're down to our last few minutes. So what do you think about this embodiment of robots and things like?
Yeah, it's certainly fascinating. I would say that's also where we see a lot of the power of developing systems that are able to abstract beyond text and generalizing the concepts, generalizing the learning mechanism towards all these different other applications and the embodiment components. It's fascinating because obviously we all would like to see a Gen AI system also being able to control a physical device itself. It makes me wonder though, and this is where almost I'm at, more on the components that are more around the technology, social impact, the ethical impact. It makes me wonder sometimes what would happen if a Gen AI system were to hallucinate on the physical level, as a robot. What does that look like? And what would be the implication there? There is so much we don't know about these systems. Obviously, we all want to go in that direction, but it makes you wonder what could happen and what could be some of the situations that we haven't even thought about. And so all of these ethical components, all of these societal components, because you're completely right in saying right now the price point might be more on the expensive side, but it will soon be going down to a point where it's going to be maybe $20,000, $30,000. I think the Optimus is priced to be at some point at the $30,000 level. So it makes you wonder where we're going to get there. I definitely think that's the way to go. It just makes me wonder, how can we get to that point where we're going to have these assistants or these systems that can perform all of these dangerous tasks or tedious tasks for us, but at the same time also have an interaction with humans that's not detrimental, in terms of being dangerous in some ways, but also in terms of being able to coexist in the same environment, and also as an economy, keep on thriving, but also making sure that humans have a good way of carrying on with their life. So I definitely think that's the way to go. Just wonder, how can we get there in a way that marries technology and also the societal components?
China's already released that they're allowing taxis. So there's actually basically robotic taxis. So embodiment of AI into a car where it drives, and there's they're allowing it, right? So in China, there's taxis that are autonomous, and Waymo, for example, in Phoenix, Arizona. So again, I recommend the audience kind of research themselves, but Waymo is also in some cities now, they have autonomous vehicles where you can hail a car, but it drives by itself, things like that, right? In parts of California, I guess, and in Phoenix, Arizona, it's already released. People can use it. So that's really a generalization of an embodiment, right? But in car form. So I think that's really interesting. But we're down to a few minutes, and I got a hard stop as well as you do. What are the things that you're doing that we haven't discussed yet? So one of them is Columbia, but are there others? Can you talk about what you're doing at Columbia University, and then some other things that we haven't talked about in a prior interview?
Yeah, definitely. Well, I'm just fascinated about seeing, how many misconceptions, I would say, there are on the AI side. We're all now part of this AI revolution, so to say, not just those that work with AI, as it used to be a few years ago with deep learning, but also now with a lot of users, with a lot of consumers that are consumers of the technology itself. And there are a lot of misconceptions, there are a lot of people that claim to be experts and people that are actual experts that are very humble about it. So I do find it really fascinating to kind of be able to maybe teach is the wrong word, but to some extent, convey the right knowledge to people, especially to young audiences, about what's right and what's wrong about AI. What are some of the misconceptions, and what are some of the actual ways that we can leverage it? And so teaching young students is something that I'm really passionate about, and it's trying to teach the younger generations about what does artificial intelligence look like. I do realize that for someone coming from a technical background, it's pretty clear. But for other folks, especially those that want to get into the industry or are just interested in learning more, it's a very confusing concept, and even experts will tell you there's no clear definition, there is no clear agreement on what AI is. So I find really interesting to see, and probably we should have more experts trying to teach younger generations on how to leverage AI for good, for some of the positive applications. I know you're very involved with the US AI for Good initiative. And that's a great example of that too, is how can we show younger generations and not so young generations how we can use the AI for our own benefit, but also trying to remove some of those misconceptions and some of those thoughts that are actually erroneous. And it's extremely important, especially with younger audiences, because they are the ones that right now are having those challenges with AI in education, and should it be a tool or should it be something to avoid? And so how can we better basically teach them how to navigate this new environment that's extremely complex?
So that's where you're teaching at Columbia then? Or...
Yeah, younger students. I tend to be pre-college students and also high school students sometimes.
Are there any other areas that we didn't discuss in our prior interview, which are new to the audience that you're doing? And we have about a minute left, so we don't have a lot of time.
No, really. Just more on the writing side. I do like a lot how we can now be able to bridge a bit the gap between technical aspects and non-technical aspects. And so I do find myself very interested in also thinking and writing about how can we discuss about the non-technical aspects of AI. And that's definitely something that I find fascinating, because it looks like we almost nailed on the technical components, but we do have a lot of open questions on the non-technical side. And so definitely, I think there is a lot of fascination, at least from my side, in terms of thinking through some of the societal and ethical implications of AI and sharing it with the world.
So, Eugenio, you've got 30 seconds. Any final recommendations to the audience?
I would say definitely to embrace artificial intelligence, but also be a bit skeptical about it. There are a lot of preachers, there are a lot of people that claim to be experts, and a lot of also challenges in terms of using artificial intelligence. I tell people all the time that GenAI is not always the answer. It might be really interesting and might be something that we do want to do, but it might be sometimes not the right application. So I always preach to be skeptical about AI in a positive way. So wanting to go ahead in that direction, but also being careful about the fact that it's an extremely powerful tool, and sometimes it's not the right one to use.
I guess I would use the word critical thinking. So apply critical thinking as a skill.
Absolutely.
As you evaluate what's happening. So Eugenio, thank you for coming in and sharing your insights with us. You are an amazing individual doing so many notable things globally. I recommend the audience look at his profile because you definitely are a change maker and an innovator. So thank you for coming in and sharing your insights with my audience.
Thanks, Stephen. It's been a pleasure being here.
Thank you for listening to the Brand Called You videocast and podcast, a platform that brings you knowledge, experience, and wisdom of hundreds of successful individuals from around the world. Do visit our website www.tbcy.in to watch and listen to the stories of many more individuals. You can also follow us on YouTube, Facebook, Instagram, and Twitter. Just search for the Brand Called You.